Hello everyone, you are welcome to my class, and this is my digital tutors. If this is your first time stopping by, do not forget to subscribe, follow, depending on the platform you are watching this from, be it YouTube, Facebook, TikTok, other social media platform, and please help us to share, like, and also comment as well. So in today's class, we are going to look at this question, a SAT question on wave. So the question says that a rope stretch between a fixed point can support transverse standing waves. What is the ratio of the sixth harmonic frequency to the third harmonic frequency? So in a standing wave, when you have here is a string fixed at 2 points. So when you disturb this, plug it. So the frequency known as the first frequency, known as the fundamental frequency, which is the faint frequency, right? So this will give us a single loop. Let's call this one the incident, and here is the reflected. It will give us a single loop. So, and this single loop, we call the length of this to be L, from here to this to be L. So this single loop is the same thing as half of wavelength, lambda over 2. Look at a full wavelength is this, something like this, right? That is incident, then this is the reflected. So take note now, a full wavelength is just like 8, figure 8, right? Right? A horizontal figure 8, let's put it like that. So here is a full wavelength from here to this point, is a full wavelength. So from this point to this point is what? Half wavelength. So that's why I said the length of this first, when it was plugged, right, or disturbed, it formed this single loop, which is equal to what? Lambda all over 2. So, and from the fundamental formula for wave, we have V, the velocity of the wave, equal to frequency f lambda and the wavelength. So from here, our frequency will be equal to V all over lambda. Now, from what we have here, that the length of the string is equal to lambda all over 2, this implies that lambda is equal to 2L. Is that understood when you cross multiply? So this implies that F will be equal to V all over 2L. So this is our first frequency, right? Which is known as the fundamental frequency, or otherwise known as the first harmonics. So here is our first harmonic frequency. First harmonic frequency, which is F naught equal to V all over 2L. I hope you are following small. Okay. So here is our first harmonic. So if I disturb this more than the first one, we are going to have another, let me do it here, another set of standing wave formed, which is going to be like this. So here is the incident, here is the reflected. So remember, it's a fixed position, right? So like what I've just illustrated over here, from here to this point will now become our length, which is equal to the same thing, because the whole of this is 1 lambda, so the wavelength is lambda. So from here also we can use this formula, F equal to V all over lambda. So anywhere we see lambda now, we put L, just like what you do here. So it goes to be V all over L. So F here now become F1, the second harmonics, which is equal to V all over L. Are we following? Okay. So if we are going to write the first harmonic in terms of the second harmonics, then if you look at this, let's do that over here to manage our space. Okay, if you look at this, you have F naught equal to V all over 2L. I can rewrite it as equal to 1 over 2 times V all over L. It's still the same thing. Am I correct? So now I want to make V over L subject to the formula so that I will divide both sides by what? 1 over 2. So when I divide both sides by 1 over 2, then I'm going to have F naught divided by 1 over 2 equal to 1 over 2 times V over L divided by 1 over 2. So that 1 over 2 comes 1 over 2. That implies that V over L will be equal to, when I reciprocate, I'm going to have 2 F naught. So it's 2 F naught. So this implies anywhere I see, right, anywhere I see F1, no, V over L is equal to 2 F naught. Is that clear? So, and my F1 is equal to V over L. So my F1 is the same thing as what? 2 F naught. So my second harmonics is a multiple integral of the first harmonics. Is that understood? So that is one. Now, for me to get other harmonics, let's say this one now, then when I disturb the string more, I'm going to have something like this. Yes, I have something like this. So this is the incident. So the reflected will be like this. The reflected will be like this. Are we following? So from here, we say here is our L length. Now, since from here to here is one wavelength and here is a half wavelength, so I'm going to have one wavelength plus what? Half wavelength, which is lambda over 2. That will give us what? 3 lambda all over 2. So this implies that our length is equal to 3 lambda all over 2. So if we use the same formula, V equal to F lambda, we end up having our F equal to V over lambda. And when you make our lambda subject of the formula, V over lambda, when you make our lambda subject of the formula, we are going to have 2L over 3. From here, I have L equal to 3 lambda over 2. If I make lambda subject of the formula, it's going to be 2L over 3. So I'm going to have V all over 2, 2L over 3. So that my F will be equal to, when I reciprocate, I'm going to have 3V over 2L. Are we together? So 3V over 2L. So that is my third harmonics. So that is F2. So my F2 is equal to 3V over 2L. What is V over 2L? V over 2L is my first harmonics, which is 3F naught. So let's write it as 3V over 2L. So as you can see, there's a kind of progressive increment in as we move from first harmonic, second harmonic, third harmonic. Our first harmonic is this. Second harmonic is 2 multiply the first harmonic. Third harmonic is 3 multiple of what? Of the first harmonic. So you expect that my fourth harmonic F naught, F4, right? No, that will be F3. My fourth harmonics will be equal to 4V all over 2L. My fifth harmonics will be equal to 5V over 2L. And my sixth harmonics, F5, will be equal to 6V over 2L. Are we together? So, and what the question asks us to do, where will I be able to write this now? So what the question asks us to do is to find the ratio of the sixth harmonics to the third harmonics. So our first harmonic is here. Our first harmonic is here. right? Which is this F naught. This is second harmonic. This is third harmonic. So our third harmonics is this one. Take note of that. And our sixth harmonics is this one. So we are taking the ratio of six harmonics to what? The third harmonics. So let's do that. I'm going to manage this with another marker. So ratio of six harmonics, which is 6V over 2L, ratio third harmonics, which is 3V over 2L. So ratio is a form of fraction. So I'm going to have 6V over 2L all divided by 3V over 2L. So when I reposition it, that will be 6V over 2L multiplied by 2L over 3V. So 2L we cancel 2L, V we cancel V. I'll now left to what? We left it 6 over 3. 6 divided by 3 to give us 2. So our answer is 2. From the options here, our answer is 2. I hope it is understood. So if you like this and enjoy this, please don't forget to follow me. Subscribe to my channel. We have a lot of this kind of question that we're going to be putting in place. Thank you. God bless you.